real.
This is math for real people.
So what Lindsay and I are going to show you today is the rule of exponents. So Lindsay's going to help me out. We have a little visitor, very little. So you can see the rules for exponents right there. And the first one says when you're adding and subtracting, nothing happens to your exponents. Got that, Lindsay? So nothing happens. It's just like combining like terms. So let me give you an example of that. So here's the example. So when you're adding and subtracting, nothing will happen to my exponents. It's just like combining like terms, and that's a video too if you haven't seen that yet. So the only terms we can combine here are the x's squared. So there's a 3x squared and a 5x squared. The coefficients are the only things that can come together. So we have an 8x squared plus 7x, and you can't combine anymore because there's none with the same variable to the same exponent. So you're done. So that's adding and subtracting. Now we'll talk about multiplying. Okay, so here's a problem where you have things being multiplied with exponents. And what is that, Lindsay, that you have to remember?
About the base, no trouble. About the base, no trouble.
Good job.
About the base, no trouble.
So like Lindsay's saying, it's all about the base. The bases have to be the same in order for you to do anything, and you keep them the same. So like the rule says, if it's the same base, the exponents will be added together. You keep that base, right?
Yeah.
So you do 2 and you add 10, and that's it. Now if it looks a little different, you might have something like this: 3x to the 5th times 7x to the 4th. That's okay because the exponent is still to the base. It's still to the base of x. So you do the same thing you always do with your whole numbers, and that turns into 21 because it said to multiply. Then your exponents are with your x, your variable with the x, so you're going to add them. So it's x to the 9th. And that's what happens when you are multiplying. That's what your exponents do. As long as they have the same what?
About the base, no trouble.
Okay, so we've talked about multiplying. Now when you are dividing, that's the opposite of multiplying. So instead of adding your exponents, you are going to subtract your exponents, as long as they have the same...
About the base.
Exactly. Has to have the same base. So if it's a 2, you do the top subtract the bottom every single time. So 8 subtract 4, you leave the base, and you get a 4. And you're done. You can multiply it out. Remember, that means 2 times 2 times 2 times 2. And then you'd be done. But sometimes you can finish like that in your textbook. So looking down at this one, the whole numbers, the coefficients in the front, stay the same. So you do 12 divided by 3, and then y to the 5th over y to the 2nd leaves you with y to the, subtract it, and you get 3rd. 5 subtract 2 gives you 3.
Can we watch this video when we're done?
We sure can. Okay, and the last part is raising an exponent to a power, like you can see on the board here. There's, when you just have an exponent, so it's x to the 3rd raised to the 5th power, that's when you finally multiply. And you get x to the 15th power, and you're done. Well, what you want to be careful of is if it's the whole thing in parentheses raised to the power, that means that power goes to that one and that one. So technically you have 3 cubed times x. Well, if you raise it to the power, you multiply it, so it's x to the 6th power. And then you can do 3 times 3 times 3, which is, do you know that?
About the base.
3 times 3 is 9, times 3 is 27, and it's all about that base. And you are done. Thank you.
Thank you.
You got that?
Yeah. Got that.